Welcome to Power One's Digital Power Technology webinar. We'll focus on a system-level approach to designing complex embedded power systems using digital power technology. We'll also discuss how dPWER increases the power system's functionality and capability while reducing design complexity and cost. Digital power provides a means to bring fully featured programmable control to DC-DC embedded power conversion. The dPWER system is designed to maximize capability and functionality while reducing design complexity, board space, and cost. Digital power control allows for precise power conversion over the range of load and input voltage, without many of the losses associated with analog circuitry. The use of digital technology is especially helpful at lighter loads, where digital current share can maintain balanced loading. Digital power is an inherently green technology, and the telemetry feature allows the system to monitor operation and make decisions that can increase overall system efficiency and reduce operating costs. Are you considering digital power? Not sure what applications are well suited for digital power? If you answer yes to any of the following questions, then it's time to see what digital power technology can do for you. Is there a need to control the turn-on and turn-off profiles of the outputs? Is there a need to manage and contain faults in a system? Is there a requirement to monitor voltage, current, or temperature at the system level? Should the power system be able to margin outputs during production tests? Is there a need to minimize output voltage transients during step-load current changes? Is system noise reduction required? This can be achieved through PWM synchronization and phase interleaving. Is there a need to quickly change the configuration of the power system without making any hardware changes? If so, the choice is easy. Power One's totally integrated dPWER technology is the only system-level solution available on the market today. The Digital Power Manager system architecture utilizes a graphical user interface to communicate with the Digital Power Manager IC. The Digital Power Manager is the brains of the system and communicates with each point-of-load device via a single-wire communication bus. There are no external components required to implement digital power. This fully featured system is contained within the Power Manager and the digital point-of-load devices. Every parameter of the digital point-of-load device can be adjusted through our GUI software, and configuration settings are saved and retrieved upon startup of the system. The status of each point-of-load device can be monitored continually during system operation and accessed via the I2C bus. The Windows-based design tool provides a user-friendly interface for designing and simulating the power system. The Design Wizard helps select the proper point-of-load modules, configure each module, provide simulations, and monitor system performance. This screen highlights some of the features of a digital power system. The traditional analog approach has a limited feature set, and to add functionality requires additional circuitry, which increases costs and wastes precious board real estate. dPWER is the only system-level integrated solution that includes point-of-loads, power management, communications, and a set of development tools that does not require the user to become an integration manager. When comparing dPWER features and capabilities to a traditional analog power system implementation, it's easy to see why digital power is becoming the solution of choice. All of the critical point-of-load parameters are programmable, including set point voltage, switching frequency, turn-on and turn-off delays, protection thresholds, and feedback loop compensation. Earlier we talked about how the Digital Power Manager is the brains of the power system. The DPM can control up to 32 independent point-of-load devices. The DPM communicates with the host system via an industry-standard I2C interface. It also acts as a storage device for configuration data, assures data integrity through cycle redundancy checking, and provides system supervisory functions. The dPWER communication scheme uses a standard I2C interface between the dPWER system and the host controller. The single-wire SD bus allows the point-of-load devices to communicate with the Digital Power Manager and is isolated from the system, reducing data traffic on the I2C bus. dPWER has 4 auxiliary channels to control non-dPWER devices such as fans, LDOs, VRMs, and even analog point-of-loads. One of the powerful features of a dPWER system is the telemetry capability. The Digital Power Manager continually collects voltage, current, and temperature data for each point-of-load device. The collected data can be sent to the host system via the I2C bus. Telemetry data is key to optimizing system performance, increasing system reliability, and reducing design cycles. Additionally, telemetry data adds the capability to do remote troubleshooting. dPWER changes the entire power system design approach. Using the Windows-based design and simulation tools, in conjunction with the ability to change parameters on the fly, a complex power system with multiple point-of-load devices can be designed quickly and with ease. Analog designs require hardware changes and PCB respins, which introduce long delays. A complex power system can be set up in 2 to 3 days using dPWER versus 8 weeks with an analog approach. Simple power systems with only a few point-of-load devices can be set up in a few hours using dPWER. Digital power is ideal for high availability systems where it's necessary to monitor output current and voltage and compare it to temperature data to predict if the system is operating properly. When systems become unstable, preventative maintenance can be scheduled before system failure. The ability to design a fully featured, configurable power system that minimizes board real estate by reducing the design complexity and overall power system cost provides a compelling business case that's hard to argue against. dPWER is the solution of choice. What customers really like about dPWER is its flexibility. You can implement almost any functionality within the power system. It's easy to make significant changes to the operation of the systems without a single component change. dPWER works no matter what the load turns out to be or how power requirements change. It's also proven to work with DC and AC front ends. dPWER offers a very simple hardware design. In addition, dPWER provides the ability to characterize your own hardware. Most customers usually don't know what their power requirements are before their system is built, so the telemetry data collected provides this information. dPWER offers a wide feature set, but there are some features that stand out and are worth repeating. The ability to optimize the control loop results in optimized output capacitance, helping to free up board space, reducing component count, and reducing cost. Frequency synchronization and interleaving reduce both input and output noise of the point-of-load devices without adding external filtering. The ability to monitor output current, voltage, and temperature enables customers to characterize their equipment, cost optimize the power system, and catch potential reliability problems. The ability to current share without external components, program fault protection thresholds, and the ability to program the speed of transient response are a few more features that set dPWER far ahead of other solutions. Power One invites you to investigate digital power further and in your own lab. The dPWER Evaluation Kit is available for purchase. The kit contains everything you'll need to put dPWER through its paces and truly understand why digital power is the way of the future. This concludes the presentation. Thanks so much for learning more about digital power technology. Are you interested in learning more about dPWER digital power technology? To learn more, contact your Power One Regional Sales Manager, email us at dpower@power-one.com, or contact one of our regional sales offices. You can also visit us on the web at power-one.com.